On June 5, 2026, the International Space Station reached a high-pressure breaking point. High above Earth, routine orbital science was replaced by an emergency scramble. Houston issued a rare directive, forcing American, French, and Russian astronauts to don their spacesuits and seal themselves inside a docked SpaceX Crew Dragon capsule. This evacuation was triggered by a mechanical saw. Inside a fractured, aging module, a Russian cosmonaut was preparing to cut into a structural component, and NASA feared the operation would destroy the station. The two space agencies were locked in a literal standoff in a vacuum, unable to agree on the engineering required to keep the hull from ripping open. This 3D model of the ISS highlights the crisis center, the PRK module. It's a 1-meter transfer tunnel at the rear of the Russian Zvezda segment. Years of heavy cargo ships slamming into this port sent kinetic energy through the walls, slowly degrading the metal. Engineers spent years tracking drafts with dry tea leaves and floating paper, patching microscopic fissures as they appeared. But by the summer of 2026, these improvised patches were failing. This timeline tracks the sudden damage spike. In early June, the leak rate accelerated, with engineers identifying 16 distinct cracks in days. The station's breathable air bled into the vacuum of space at a rate threatening to overwhelm life support systems. The PRK module had become a severe structural liability. The metal was actively failing under the constant outward push of the station's internal atmosphere. Roscosmos proposed a radical repair strategy. They intended to drill holes into the cracks to stop them from spreading, and then use a mechanical saw to remove a load-bearing bracket to redistribute the tension in the hull. Houston was horrified. Roscosmos had not provided any safety data or mathematical modeling to explain how the weakened hull would survive the removal of a structural component. This cross-section shows the physics behind NASA's objection. The station's interior air is held at roughly 14.7 pounds per square inch of pressure. Severing a load-bearing bracket while it's actively holding back a vacuum puts immense localized stress on the compromised metal. NASA feared this would trigger a process called unzipping. Under constant outward pressure, a small fissure can propagate along a structural seam in milliseconds, tearing the metal wide open. If the hull unzipped, the entire atmospheric contents of the module would violently flush out into space, resulting in a rapid, explosive depressurization of the station. NASA viewed the repair as a mathematically unacceptable risk. The probability of catastrophic failure was simply too high. On the morning of Friday, June 5th, Roscosmos ignored NASA's warnings. The Russian cosmonauts drifted toward the station's fractured wall with their tools and prepared to start the cut. Houston realized the station could be minutes away from a hull breach. They pulled the trigger on a drastic safe haven directive. The crew of the station, including American astronauts and French astronaut Sophie Edenot, were ordered to immediately evacuate the central modules. Even Russian cosmonaut Andrei Fedyaev was forced to seek refuge in an American escape capsule as the entire crew prepared for a potential catastrophe. The astronauts suited up and sealed themselves inside the docked vehicles. They were strapped into their seats, ready to detach and descend to Earth if the repair caused the station to unzip. The threat of a hull breach was so severe that abandoning the multi-billion-dollar outpost was considered the only safe option. The sight of international astronauts fleeing into lifeboats finally forced Roscosmos to back down. The repair was aborted, and the saws were put away, but the leak remained, leaving the agencies with an engineering dilemma. They could no longer agree on a physical fix for the failing module. Looking back at the 3D model, you can see the final compromise. Instead of attempting another repair, they chose to seal the hatch. This interior door will remain locked and hermetically sealed for as long as the station stays in orbit. Uncrewed cargo ships can still dock at the exterior port to transfer fluids through external bypass pipes, but human beings will never enter this compartment again. With its retirement scheduled for 2030, the station's final years are being managed through a strategy of isolation. As the infrastructure ages, it is becoming safer to permanently lock the door on a damaged module than to risk a catastrophic repair.